Now here we will discuss the flash ADC, analog to digital converter. Now in the syllabus, two different types of ADCs are mentioned. One is a flash ADC and another one is a successive approximation. Now before going to discuss the flash ADC, let me explain about the comparator. So what is comparator? Using operational amplifier. In the fourth unit we didn't study the operational amplifier using comparator. Comparator using operational amplifier. Now this is the comparator which is having the two inputs. Now here I am applying the V1 voltage and here I am applying the V2 voltage. Now there is no feedback. We are not applying any feedback signal from the output to the input, to either to the positive terminal or to the negative terminal. So no feedback. If the feedback is not connected to the negative terminal means what? What is the gain? Gain is infinite. So gain is infinite means what? It will compare these two voltages and it will give the output. Now if I am taking this is a plus VCC and here it is a minus VEE, then my output will swing between plus VSAT to the minus VSAT. Now this is the plus VSAT and this is the minus VSAT. So what is plus VSAT? Now if your positive, now whatever the signal is connected to the positive terminal, if this positive terminal voltage is greater than the negative terminal voltage, then the output we will get the plus VSAT value. This plus VSAT value depends on the plus VCC and minus VSAT value depends on the minus VEE. How much magnitude we have connected here? 90% of the voltage we get at the output. And theoretical ideal case you can say it as a plus VCC and minus VE also you can say ideal condition, but practically what? Plus VSAT and minus VSAT, it is the voltage is less than this maximum voltages. It is 90% of the voltages what we applied over here. If the negative terminal voltage is greater than the positive terminal voltage, then we get the minus VSAT value. Now this plus voltages we can consider it as a logic 1. And this minus voltage we can consider it as a logic 0. So this comparator is comparing the two inputs and giving the logical values, either logic 0 or logic 1. So this is about the comparator. This comparator we are going to use in the flash ADC. So this flash ADC will compare the reference analog voltage with the reference voltage and it will convert that analog signal into the digital signal. So how it is going to do that we will see in this flash ADC. Now here let me draw the diagram for the flash ADC. Now here how many number of bits? Now I am taking here 3-bit flash ADC. So here means what? I am taking one priority encoder. Here I am taking only 2 digital outputs. So now here I am taking the 2-bit flash ADC. I am taking only 2 now B0 and B1. 2 binary bits I am getting. This is nothing but what? Binary output or digital output. So here I am taking the priority encoder. So already you know the relation between in the encoder. If I am getting, I have a 2 outputs means how many number of inputs are there? Here n outputs. I have to take 2 to the power of n inputs. That is nothing but what? Total 4. Now here I am taking 0, 1, 2, 3. So 4 comparators I need to. So 0 I am applying always to the logic 1. So here I am applying to the logic 1. So I need if 2 binary values, if I am representing the analog input with the 2 binary values, then I need the 2 to the power of n minus 1 comparators. Means what? If I need 2 means what? 2 to the power of 2 minus 1. So 4 minus 1 is 3 comparators I need at the input. So what is comparator? Just now I have explained, okay. So here this is one comparator and this is one more comparator. So comparator 1, comparator 2, comparator 3. So now here it is having the minus and plus, plus minus, plus minus. For minus terminal I am applying the, now minus terminal I am applying the reference voltage, okay. So now here one resistor, one more, total 4 resistors we have to take and those are equal resistors R. And here I am applying the V reference. Now what is the voltage at this point? V reference divided by 4. Apply voltage divider method. So now what is the voltage at this point? 2V reference divided by 4. Now what is at this point? 3VR divided by 4. So this is the 4 resistors I have taken connected in series. So voltage, not in series actually, point is going to the op amp, but you know that into the op amp no current flows. That's why all are considered as series and apply the voltage divider. Now for positive terminals, I am applying the analog input voltage. Now here I am applying the analog input voltage. So this is the V analog. So this voltage is compared with the reference voltage, and these comparators are giving the logic 0 and logic 1. So thereby this priority encoder is converting these by digital values into the binary. So these digital outputs to the digital. Now here it is giving the analog equivalent digital outputs for this equivalent analog value. Now let me draw the truth table. So now here I am taking the analog input, analog input Now here comparator outputs and digital output. Now this digital output I am taking, digital output. Now here digital outputs are B0, B1. Now comparator 1, 2, 3. So here I am taking C1, C2, C3, and analog input values directly I will take analog input. Now if my analog input is between V reference to 2V reference, now in between these two, at that time my comparator 1 will be high. So if the value is between, first one is 0 to, my analog voltage is between 0 to V reference by 4, then all comparators at the beginning it is 0. For all zeros it will give the 0. Now here let me explain that. Here I am applying the comparator. Already you know that comparator, if the positive value is more, then we will get the logic 1 over here. If the negative value is more, then we will get the logic 0 over here. Now whatever the VA, now here it is VA is applied. Now here it is V reference by 4. If the VA value is more, then here we get the logic 1. Here the V reference by 4 is more, then we get the logic 0. Now for example, to understand the concept, I will take V reference is equal to 4 volts. Then what is the voltage at this comparator? Now this comparator voltage, here it is 1 volt, here it is 2 volts, here it is 3 volts. Now if I take analog voltage, now if voltage is varying from 0 to 4 volts, then now let me take, now here if it is a 0 voltage, now which voltage is more here? Negative terminal voltage is more, negative terminal voltage is more, negative terminal voltage is more. Thereby we get the output here 0, 0, 0. If priority encoder all inputs are 0, 0, then it will give the 0, 0 output. Now this is the, now if I am applying the 0 voltage at the input, then I will get the 0 binary output. Similarly, if I apply the less than 1 volt, if my value is less than 1 volt value, if my input value is between 0 to 1 volt, any value, if my input is 0 to 1 volt, then at the time also I will get the all zeros. So here I can write it as, if my input value is less than 0 to V reference by 4, then I will get all the values are 0, 0 only. Now if I apply the 1.1 volt to 1.1 volt to 2 volts, now here 1.1 volt to 2 volts. Now in this case what happened? Positive voltage is more, that's why we get the logic 1 over here. Now in this case what? Negative voltage is more, that's why 0 and 0. So what we understood, if I apply the voltage between V reference by 4 to 2V reference by 4 is nothing but what? 1 to 2 in between if I apply, then my comparator 1 value is more. So V reference by 4 to, my VA is in between V reference by 4 to V reference by 4, then my comparator 1 is logic 1 and the remaining 2 comparators are 0. Why? Because here the positive voltage is less than the negative voltage, that's why I'll get 0, 0. Now in this case, so this priority encoder will generate the 0, 1. Okay, so now if I apply the input voltage 1 to 2 volts, now for that it will give the 0 1 as a digital output. Now similarly, if I apply the voltage between 3 to 2 to 3, now here it is plus minus, here it is plus minus, now again. So now if my voltage is 2 to 3, now here it is 2, it is 3. So if it is 2 to 3 means what? This positive terminal voltage is more, that's why here we are going to get 1. And here the positive terminal 2 to 3 means what? It is less than the 3 volts, so he will get 0 only. So now here if my voltage is between 2V reference and here it is 3V reference, in between these two voltages, then I will get 2 comparators outputs are 1 and the last comparator 3 is 0. So for that it will give the 1 0. So now if I apply the voltage between 2 to 3, then I will get the 1 0. Now again if I apply the voltage between 3 to 4, then all the 3 comparators outputs are 1. Now if my voltage is V reference 3V reference by 4 and VA between V reference. So if it is a 3 to 4, then all 3 comparators or outputs are 1, thereby I will get the output 1 1. Now this is how the analog signal is converted into the digital signal. Now here we have taken 1 1 voltage. If for every 1 voltage 0 to 1 I am getting, now if I am taking the analog voltage is 4 volts. So 0 to 1 I will get the 0 0. 1 to 2 I will get the 0 1 and 2 to 3 I will get the 1 0 and 3 to 4 I will get the 1 1. Now here analog voltage how much you will take, depending upon that we get this binary values. If you want more accuracy, instead of getting total 0 to 1, if you wanted to get the for every 0.5 voltage, then you need to increase the number of digital outputs and thereby number of comparators. So then we can get the more accuracy. For every 0.5 volts, 0 to 0.5 if you want the digital output and 0.5 to 1 volt if you want the digital output. That time we need to increase the digital outputs. Here comparator will increase and the number of resistors increases, then we get the more accuracy. This is about the flash ADC, how it is converting. Thank you.